So I'm going to talk about what climate change looks like in Saskatchewan, and in particular what it could look like down the road. And it might be a bit different than most of the talks you've heard about climate change, because my talk is informed by my affiliation with PARC for the past 20 years, somewhat unique environment in which to do research. PARC was launched in March 2000 by the Minister of Natural Resources, the Honorable Ralph Goodale. Thanks, Ralph. Are you still there? There he is. I'm not sure how many times I've thanked Ralph for the fact that he was minister when his ministry created PARC. And PARC was given a mandate of doing climate change research, but in support of adaptation. So all of the research that PARC has done has been for a particular client, if you want to think of it that way, in a business model. But there has been a government agency, a First Nation, a private company, a municipality, an NGO. There's been somebody who has asked us to consider how they're being impacted by climate change. And so what's unique is that the research is done in collaboration with some kind of external partner, which has involved spending a lot of time off campus. And for that reason, for the past 20 years, I've been teaching exclusively via the internet. I never meet the students. If you're one of my students, can you raise your hand, please? Hi. Nice to meet you. Yeah, that's great. I just met a couple of my students. So I mentioned in response to Sarah's question, yeah, I've been asked to give more than 400 talks on climate change, but I can because I don't spend time in the classroom. I teach, but it's via the internet. So for example, next month I'm speaking in Vancouver and in India, but I'll also be teaching because I just bought an iPhone 11 Pro. It's amazing. So all you need now is a smartphone in which to communicate with your students. So in that respect, PARC has been an interesting place to work, but also, like I said, our research is informed by the end user. You know, we're scientists. We can create reams and reams of data, but data is simply numbers unless there's some kind of context. That context might be some terrific scientific problem, but in the case of PARC, the context is the user that needs the information that we produce. And so we're able to transform the data into information and ultimately into knowledge only given our relationship with the organization for which we are producing the information. I won't go to wisdom because that's beyond the scope of science. And if you find wisdom, please let me know. It seems to be lacking in our world. So not only do we need some kind of context to create understanding of climate change, but the context also informs the type of data that we produce, the type of research that we do. I'll give a couple examples. This is a weather forecast for the year 2042 for April 1st till May 31st. Seems kind of bizarre, but technically we can generate weather forecasts for the middle of this century. But it's just a bunch of numbers. It has no meaning without some kind of context. For example, working with and getting to know Bev and Keith Everetts, who are organic beef producers, and learning how their operation is affected by weather and climate, and what they've had to do in order to withstand storms, drought, flooding, and so on, and succeed as beef producers. Something else that's unique about PARC is captured in this slide, and that's the other people. You can see Keith and Bev. Beyond that is at the time, a PhD student in sociology. Then, to her left, the director of the Swift Current Creek Watershed Stewards. The other people in the background are PhD students in sociology, geography, and engineering. By the way, that first person I introduced is now an associate professor at the U of R. Our research is very much interdisciplinary. It's not possible to study climate change and all its manifestations from the perspective of a single discipline. It just doesn't work. However, disciplines are the way that universities are structured. And I like to cite a clever person who said that the world has problems, universities have departments. We couldn't do this research without PARC, and believe me, I tried. I've tried to support students in psychology, sociology, engineering, as a professor of geography, and I was told, you can't do that. There's no mechanism for a professor to support grad students in somebody else's program. But PARC can do that. We don't have that constraint. Here's another user of our information. It's a First Nation. This is on the James Smith First Nation in central Saskatchewan. And some of the elders and members of the tribal council are leading us through this hoar-frosted forest down to the Saskatchewan River. Now, we have lots of data about the Saskatchewan River, but they have much more information than we do. They have a ton of information from observations they've made of the Saskatchewan River that are considered beyond the realm of science, but perfectly valid observations based on a lifetime of living next to this river. And so Jeremy Pittman, the young man on the right, did a master's thesis where he lived with these people for weeks and gathered their observations of the ecology and the hydrology and the climate. This is an elder. This is about the closest we've been to wisdom is a person like this who has spent their lifetime in this environment and so much enhanced our understanding of the Saskatchewan River and of the impacts of climate change on their community. Jeremy's now a professor of planning at the University of Waterloo. More than 200 graduate students, postdocs, interns, research assistants have passed through PARC, and it's gratifying to know that most of them are employed because there is a demand for people who understand climate change. And that demand actually is growing quite rapidly. A few years ago, this is a magazine that I'm sure Ralph is familiar with. I'm told that politicians in Ottawa read this magazine. I was asked to write an article about what I've learned about adaptation for a policy journal. And I said, well, I'm not a policy analyst. I'm not even a social scientist. I'm a natural scientist. Oh, that's okay. Give us your perspective. And so I wrote an article and I said, look, if you're a policymaker and you're making climate change policy, talk to the people who are exposed to weather and climate. In this case, talk to the farm families on the prairies who've withstood so much in terms of extreme weather, drought, flooding, and so on. It's hard to imagine you could actually develop climate change policy without speaking to people who are affected by climate change. Because after all, scientists study adaptation, they don't do it. Adaptation is the adjustment of policy, regulations, infrastructure, laws in response to climate change. Well, the people that do that are engineers, planners, policymakers, and so we have to work with these people if we are to use science to influence adaptation. Well, somebody else is talking to these people. Researchers at the University of Montreal have been asking Canadians about their attitude towards climate change. And they've got this clever interactive website. You can choose one of the questions. I chose number of adults who think the Earth is getting warmer. And this is the result for all of Canada by writing. Across the bottom, it indicates that 83% of Canadians think the Earth is getting warmer, but that's not the case in Saskatchewan and Alberta. Notice that faint green. That faint green represents about 50 to 60% of people in Saskatchewan and Alberta think the Earth is getting warmer. And in rural Saskatchewan, it's about 50-50. So our part of Canada is unique in that many fewer people in our province and in Alberta believe in the science of climate change than the rest of Canada. Those really dark areas, that's like 90% of the people in those ridings believe the Earth is getting warmer. Now, the knee-jerk reaction of some people, especially scientists, is to say, what's wrong with these people? What's wrong with these people in Saskatchewan and Alberta? What don't they get? I don't like to hear that because these people are not stupid. Maybe there's a reason they don't think the Earth is getting warmer. Well, psychologists will tell you that there's something like 188 reasons why our thinking deviates from logic as defined by scientists. This is a codex of cognitive biases. I don't expect you to read this. We're actually doing research. Sheena Hatcher is a graduate student in psychology based at PARC. And she's developed a survey to give to ag producers to determine why only half of them think the world is getting warmer. Now, I'm not going to delve into the realm of social psychology. We're supporting Sheena and her co-supervisors in psychology to tell us that. There was an article in the Globe and Mail about a year ago where the journalists sort of summarized all of this social psychology that accounts for why people struggle to deal with climate change. And he concluded that it's hard to imagine a threat that's more likely to induce abstract thoughts. In other words, climate change, to the most part, is something that's happening someplace else to other people and far in the future. Whereas instinctively, we focus on the here and now. Because after all, for most of human history, we were concerned about where do we get our next meal. And it's only fairly recently that people have traveled around the world. And it's only recently that people have been asked to project into the future what the climate and economy would be like. It's a fairly radical idea. It's a fairly radical idea that we'd attempt to predict the future. And I know that when I was young, only rich people traveled, and only on vacation. So our global culture is a relatively new phenomenon, and as a result, people just instinctively are focused on where they live and now. And yet, climate change is asking them to think globally and in the future. Well, I'm going to stop with social psychology, that part, because that's not my realm. Rather, I'm going to suggest there's other reasons. There's actually the nature of our climate in Saskatchewan really mitigates against our recognition and detection of climate change. Next slide. To begin with, think about how the media, especially the national media, portray climate change with images like this of calving ice sheets. Next, of melting sea ice, usually with a polar bear on it. Of air pollution and heat in large cities, heat waves, or rising sea level. Now, these are very effective images. They are related to climate change, but these things don't exist in Saskatchewan. We don't have these things. So if you're concerned about climate change in Saskatchewan, it doesn't help to know that sea level is rising because it doesn't affect Saskatchewan. To some extent, we are affected by melting glaciers because that's the source of our water, but the glaciers can't be seen from Saskatchewan. And this is how scientists like to portray climate change. This is a plot, courtesy of the US Weather Service, of the average temperature of the whole world back to the year 1880. And if it was a cool year, it's in blue, and if it's a warm year, it's in red. And this is a summary, this is the average from thousands of weather stations all over the world. And it's relative to the average temperature of the world for the 20th century. So you can see that until about the 1940s, almost every year was cooler than average. And since the late 1970s, every single month but one There's this little anomalous month in blue, but otherwise every single month since the late 1970s has been warmer than average. So this is a very clear and conclusive, they say unequivocal evidence that the world is getting warmer. But there's three problems with this information. First of all, the temperature of the whole world doesn't exist. It's an abstract concept. You can't experience the temperature of the whole world. Another issue is, well, okay, but maybe this is just a natural cycle. Well, let's explore some of those questions, some of those issues with this kind of information. First of all, is it a natural cycle? Well, you can answer that question by comparing the climate of the last 140 years to the climate of the last 2,000 years. So here I am at the limit of tree growth in the Rocky Mountains at a ski resort, the Castle Mountain Ski Resort, the Tamarack Run, and so the trees on that run are tamaracks or larch. And at this elevation, trees need heat in order to grow. Above this elevation, there are no trees because there's not enough heat. And so tree growth at this elevation is very sensitive to how much heat was available each year. And some of these tamarack trees are 400 and 500 years old. So we collect this wood, we take it back to our tree ring lab, and the lab assistants who are working in our tree ring lab, like Susie and Andrea and Sheena, so on, they polish the wood, they scan it at high resolution. And we're not the only people in the world doing this kind of research, of course. A few years ago, I was approached by some colleagues from California who said, we're going to try to assemble a database of what are called climate proxies for the last 2,000 years. And we did that. There was 98 of us, and so rather than list 98 authors, we call ourselves the Past Global Changes 2,000-Year Consortium. The proxy data was from 4 sources. You can see the tree rings on the bottom right, glacier ice, lake sediments and marine sediments. In every case, if you start at the year 0 and proceed to the year 2000 on the right, in every case, the temperature of the whole world was either fairly stable or declining until about 150 years ago. And the proxy data suggests that about 150 years ago, the temperature of the Earth reversed and began to climb, and climb quite steeply. What happened about 150 years ago? The Industrial Revolution in Europe. People began to burn coal and oil and gas and change the chemistry of the atmosphere. So this is fairly conclusive evidence that something unusual is going on in terms of the temperature of the Earth. And the people that collect glacier ice, well, they have ice from Antarctica or Greenland, Gavin would know, 600,000 year record. And in that context, this is a relatively unusual rate of climate change. Slide. Just to put that in context, we're talking about in the last 100 years, the Earth is warmed by about 1.5 degrees, and people say, well, it's big deal. That was the other issue with that plot. That plot showed warming of about 1.5 degrees, and people say, oh, come on, 1.5 degrees. I mean, the temperature in Regina varies by 20 degrees in a day. But this is a change of the whole world by 1.5 degrees. To put that in context, about 100,000 years ago, the temperature of the Earth changed by 4 degrees. It went down by 4 degrees. It took tens of thousands of years. What happened? A glacier formed and covered all of Canada, except a few tiny places like the Cypress Hills. That was in a response to a 4-degree change over a period of tens of thousands of years. Now, I mentioned the problem with talking about global climate change is when you pick up your phone, who's got a weather app on their phone? Almost everybody. When you look at the weather app, do you try to find the temperature of the whole world? It's not there, right? You look for the temperature where you live. And so we have to scale down to the whole world, down to where we live, if people are going to resonate with climate change, if they're going to appreciate and observe climate change, you have to talk about where we live. And of course, we live in Canada. And here's some maps that were published last year. A major report that was produced by the Government of Canada. And the headline, including CNN in the States, was that Canada is warming at twice the rate of the rest of the world. Well, that's all of Canada. The dark areas are warming at 3 to 4 times the rate of the rest of the world. And that dark area is northwestern Canada and the northern prairies. So we live in the part of the world, part of Canada that's warming the fastest, and it's warming 2 to 3 to 4 times faster than the rest of the world. Next slide. This is the cover of that report. If you can read the fine print, it says, this is the first report to be released as part of Canada in a changing climate, advancing our knowledge for action. This year, there's going to be 15 more reports released. 6, one for each region of Canada, and then a report about a cross-cutting issue like Indigenous people or water resources. So you can look forward to the news media making a big deal out of 15 reports over the course of this year. One of them will be the Prairies chapter. Next slide. And I just finished dealing with comments, 257 comments from 15 reviewers. This is quite a rigorous process. If any of you publish in scientific journals, you know that usually you get 2 referees. So you have to deal with 2 referees. For this report, we had to deal with 15 referees. Managed to address all the comments and just sent the chapter back to Ottawa. They're going to need 7 months apparently to translate it into French and put it online and so on. And then sometime in June or July, you'll hear about it in the news. There'll be a report about everything we know about climate change in the Prairie provinces. And I have to acknowledge that I've had 15 co-authors from across the prairies. Why did we do this? Next slide. Well, there's a lot of information about climate change. And here's an article where the authors traced the amount of literature. And they said between 1980 and 2014, the number of scientific papers doubled every 5 to 6 years. Well, if you extrapolate, then very soon there will be about 500,000 scientific articles about climate change. So people have to obviously synthesize. Nobody's going to read that stuff. Somebody has to volunteer to read some of it on a particular aspect of climate change and provide a synthesis. Next slide. And the other reason they need this kind of scientific assessment is to explain climate change, because in fact the climate system is extraordinarily complex. It's a system that's global in extent, has a lot of parts, and it's chaotic as well. This diagram's okay, but it's kind of land-centric. Most of the world is ocean, but of course we are land-centric. But it shows the different parts of the climate system. And actually, human activities are only really affecting 2 parts. We're changing the chemistry of the atmosphere, and we're changing the extent of native vegetation, of forest and grassland. But by changing only those 2 components of the climate system, we're changing everything else. Because all of these parts of the climate system are interconnected. There is feedbacks and interaction between biosphere, cryosphere, lithosphere, atmosphere, pedosphere, the soil, the lithosphere, and so on. There have been modeling studies where the scientists have changed the chemistry of the atmosphere, and in their model, they've held everything else fixed. So the amount of vegetation, the amount of snow, water, and so on can't vary. And by changing the chemistry of the atmosphere, we only cause a small amount of global warming. What happens is there's a chain reaction. And the first thing that tends to happen is if you heat up the atmosphere, if you trap more heat next to the Earth, the first thing to change is snow. Snow, of course, is very sensitive to temperature. If you don't believe it, Saturday is supposed to be +5 according to the Weather Network. Step outside on Saturday and +5 and see what happens to the snow. Okay, so the first thing that's disappearing is the snow, and of course ice is old snow. And if you get rid of snow and ice, more energy is taken up by the land and the air, and less energy is required to melt and vaporize the snow and ice. So when would you expect to notice global warming? The coldest part of the year. We say that Canada is losing the advantage of a cold winter. There's a bunch of advantages of -35 and -30. For one thing, there's a lot of pests, pathogens, disease vectors, invasive species that we don't have to deal with because we have, at least for a few days, extremely cold temperatures. But the biggest advantage of a cold winter is snow. Snow is the natural storage of water. It's a picture I took of Ray Glacier. I actually took this picture in 1981, so it's probably not there anymore. It's the headwaters of the Elbow River. So the water in the toilet down the hall, part of that water came from that glacier, maybe a few molecules. Because our water in Regina comes from the Rocky Mountains. It doesn't come from Saskatchewan. Well, maybe 1% of our water comes from Saskatchewan, and most of it comes from the Rocky Mountains. And we're losing the advantage of a cold climate. Next slide. Because our winters are getting warmer. Here, thanks to Nadia, graduate student at PARC, a couple of days ago, downloaded daily temperature data for Regina. And this is the lowest temperature every winter back to 1900. This is the temperature when you get up in the morning. The lowest temperature is almost always at sunrise when you're scraping the window. And there is a upward trend in our lowest temperatures. But there's a huge amount of variability from year to year. The warmest winter we've ever had, 1931. It was an El Nino, very strong El Nino. The coldest winter we ever had was 1936. You know, you hear about how horrible the dirty 30s were for economic reasons and erosion and so on. They also went from the warmest to the coldest winter on record in the same decade. But if you go off to the right, the very last point on that graph is this past winter, 2019. We thought February was brutally cold. It was actually an average winter compared to, go back to the 1960s, for example, there's a lot more very cold winters. In fact, we say Saskatchewan's getting much less cold. Based on the information that Nadia compiled for us, this is the number of days below -35 in dark blue and -30 in light blue. So far this winter, we've had 1 day below -35. It was last week. Go back in time, and there were winters in which there's 15 to 20 days below -35. So stop whining about our winter, please. It's just much warmer than it used to be. Next slide. And Rehan, where's Rehan? Dr. Rehan Anis, research associate at PARC, took the data that Nadia compiled and produced this plot showing the downward trend in extreme cold days at Regina. That's cold days. What about summertime? Summer's not getting warmer. This is the maximum temperature in the period May to August for Saskatchewan by soil zone. The reason it's by soil zone is we were asked to do this work. The Saskatchewan Assessment Management Agency came to us and said, we want to know if the cropland in Saskatchewan is getting more productive. We know it is. It's getting more productive because winter's getting warmer and the growing season's getting longer. But the high temperatures are not increasing in summertime. This is work by Samantha Kerr, PhD student at PARC, and Uli Andrzejczyk, who's a research associate at PARC. They've done a tremendous amount of analysis for this provincial government agency. Next slide, including they looked at precipitation during the growing season, which of course is critical if you're producing crops. This is the key variable. And it's going up in the last 40, 50 years. If you think back to that global warming plot, that every single month since the late 1970s has been warmer than average. Well, since the late 1970s, precipitation has been going up in Saskatchewan. Now, from year to year, it's all over the place. It's really, really wet years and really, really dry years, but the tendency is for more precipitation, which is actually consistent with a warmer climate. Warm air holds more water. That's one of the reasons. Okay, so what I've shown you is a bunch of historical weather data for Saskatchewan, showing how our winters are getting warmer. There seems to be more precipitation. The high temperatures aren't getting any higher. But what about the future? Unfortunately, we have no data for the future. In the absence of data, we have no choice but to use models. So we run climate models, and we use the data that's generated by these models. Here are two graphs. On the left, winter, on the right, summer. In both cases, the change in temperature on the vertical axis and the change in precipitation on the horizontal axis between the recent past, 1971 to 2000, and the future, 30 years in the middle of this century. I've highlighted the 0 point, and you notice that every single climate model produces a warmer climate. There's no negative values on the temperature axis, so they all agree it's getting warmer. And in winter, nearly every model predicts more precipitation, a wetter winter. A warmer winter is a wetter winter. Not necessarily snow, eventually be mostly rain. And on the right, summer, warmer, but some of the models say wetter, some of the models say drier. But even the models that say wetter, it's not that much wetter. And if it's warmer, much of that water will be lost anyway to evaporation. But I want to address a big issue here, and that's the precision of this data. Notice that according to these models, temperature could be anywhere between 1 and 6 degrees warmer in winter. Well, that's quite a range. The question is, why? Every one of those triangles is a different future climate. The color is the model. But if you pick a model and rerun the same model, you still get a different future climate. So pick the blue model. That's the Canadian global climate model. And it's kind of weird that if you run a model again and again, you get a different outcome each time. That's just a reflection of the complexity of these models. And also slight changes or perturbations in the what's called the initial conditions. So there's actually 3 reasons why these models don't agree. There's different models in blue. There are different assumptions about the greenhouse gases. How much more greenhouse gas will people produce? The more gas we produce, the warmer the climate gets. And if it's not the model or the emission scenario, then it's just the natural complexity and internal variability of the climate system. Now, for the 5th assessment report, the IPCC did an analysis of the relative contribution of these 3 sources of uncertainty to predicting the future climate. And as we go forward, the source changes. Because in the near term, and this starts in 2013 on the left, well, for about the first decade, natural variability is important because the greenhouse gases don't necessarily affect the climate that much in the short term. But in the longer term, as we go to mid-century and beyond, you can see the green area, greenhouse gas emissions become increasingly important in determining the future climate. There's some disagreement between models. That disagreement tends to peak around 2030. Relatively speaking, the model has become more reliable, and that's because just more of the variance is explained by the greenhouse gases. Okay, so this is for the whole world. Well, a couple of years ago, I was having coffee at the Naked Bean with Dr. Elaine Barrow, who's a colleague of ours based in Regina. And I said, Elaine, why can't we do this for the Canadian prairies? She goes, okay, I'll go home to my house. She works out of her house in Cathedral. I'll go home and I'll download a whole bunch of climate model data and do the same thing. I want somebody to do a drum roll, do a drum roll. Da-da, the outcome. Which was kind of interesting. So the International Journal of Climatology published this. On the Canadian prairies, the greenhouse gas emission scenarios don't really affect our prediction of the future climate until later in the century. And when you use different models, we can use different models, it doesn't really matter. What really dominates our ability to forecast the future climate is just the complexity of our climate system, which turns out is far more complex in Saskatchewan than just about any place on Earth. This is temperature. We did the same thing for precipitation. Check this out. If you want to understand the precipitation of the future in Saskatchewan, you have to understand the natural climate system. Because it just swamps the influence of people. Now you have to be careful how you interpret this. It doesn't mean that we shouldn't stop using greenhouse gases. It just means that our ability to predict the future in Saskatchewan is undermined by how well we understand just the natural system. Next slide. And that's because, why? Why is Saskatchewan so unique? Well, it's because we have the most variable climate in the world with Siberia. So this is some US scientists generated this map. It's the variability in moisture from year to year. The areas that are dark blue and dark brown have the most variable climates. And these occur on the transition from dry to wet, the transition from grassland to forest. So throughout most of the world, there's a fairly narrow band of blue or dark brown representing that ecotone between grassland and forest. But there's two places on Earth where it's not a narrow band, it's like a big area. And that's in Siberia, off to the far right, and next slide, and the Canadian prairies. Because there's no place else on Earth where you can be 1,500 kilometers away from the source of your water. The sources of our water is the ocean. In the middle of North America and the middle of Asia is as far as you can get from an ocean. So we already have an extremely variable, next slide, climate. So the question is, when will we notice climate change? Apparently the rest of the world has seen it. And the people in Eastern Canada have seen it. The people in BC have seen climate change. But on the prairies, it might be the 2040s or maybe the 2030s before we can actually see the effect of global warming on our temperatures. And the way that Elaine did this is you can think of it as being the difference between the signal, which is climate change, and the noise, which is the natural variability, using the analogy of a restaurant or a pub where there's a whole lot of noise and you can hardly hear the person you're talking to. So if you think of your conversation as being the signal, it's difficult to hear it above all the noise. And it's only when the ratio of signal to noise exceeds 1 that we can expect to see climate change on the prairies. Next slide. Precipitation. These are different models. Some models say, well, maybe by the 2050s, 2040s, we might notice the effect of global warming on our precipitation. But half the models say we never will. Half the models say that our precipitation is so variable on the Canadian prairies that even though it's being affected by climate change, we can't see it because it's obscured by the noise. So, just a few more slides to pull this all together. And before I get dehydrated, I gave a talk in Taber, Alberta, which was interesting. The town council said, that's nice, but God will take care of it. I respect that. I respect that perspective. One of the irrigators said to me, Dave, nice talk, but I'll believe in climate change when we get unexpected weather. Based on what I just said, when is that going to happen? When do we get unusual weather in Saskatchewan? All the time. So how do you know if it's climate change? For example, I was giving a talk in Swift Current in April 2015, and coming back on the Transcanada around Mortlach, I saw this smoke in the distance, and I was curious, so I pulled off, and there was a prairie fire. It was hot, dry, the soil was parched, and this is April. A few days before that, I was asked to give a talk in Melfort. Driving up to Melfort, the traffic was stopped on Highway 6 because the Quill Lakes were lapping over Highway 6. Now, probably global warming is a factor, because if our climate is getting wetter, we would expect higher water levels. But in Saskatchewan, our water levels go from very high to very low just naturally. So how much of that is due to global warming? It's hard to say. And the next day, I picked up the Leader Post and found this quote. One of the poor landowners whose farm was underwater said that, how do you plan for something like this? It's never happened. You hear this quite often when there's an extreme weather event, like when the floods in southern Alberta or the Fort Mac fire. People tend to say, this has never happened. That's the reaction, which is kind of human nature. It kind of bothers me when political leaders say that, because it's almost like an excuse. Of course, it's not true. Now, maybe it hasn't happened in your lifetime. Maybe by default, maybe people are using their experience as a reference. But when scientists say never happened, they're thinking beyond their own personal experience and a data set that they can get their hands on. Well, at PARC, we have a really nice data set because for a long time, even prior to PARC, but especially since PARC, I've been dragging research assistants across the prairies and collecting old wood. So, I mean, that piece of wood in the upper left corner is more than 1,000 years old. And these trees record the annual climate. Next slide. There's a living limber pine in Alberta, about 700 years old. We've collected more than 7,000 pieces of old wood, and we have a lab here with all that wood. Next slide. Here's one of the oldest pieces. I think this is from Siffler. Did you cross-date that, Sheena? Yeah. Sheena cross-dated this piece of wood and determined this tree started growing in the year 542. Well, those 7,000 pieces of old wood, next slide, have enabled us to reconstruct the climate of the prairies for the past millennium. And this is a reconstruction of the level of the South Saskatchewan River over the past 900 years. Wet years are in blue and dry years are in red. And off to the right-hand side, you can see the 1980s, those red bars. You can see the 1930s, a block of red. But prior to that, there was a drought that lasted about 25 years, just before settlers came. And it's when a guy named John Palliser said, "Don't come here." He said the prairies will be forever comparatively useless. He came here in the middle of a 25-year drought. But the government set settlers here anyway. And the rains came for 20 years, and then the 1930s came. So there is this natural decadal cycle that's evident in the tree rings. And it shows that there have been droughts. If you go back, say, to the 1500s and 1400s, there are droughts that lasted decades and decades. This isn't a model. These things happened, and they will happen again. So the biggest challenge we face on the prairies is when one of these droughts that's a decade or two in length occurs again, because when it does, it's going to be in a warmer climate. The impacts will be more severe than they were 500 years ago. Although the indigenous people in their oral histories talk about the impacts of these drought events. And so does the Hudson Bay. The Hudson Bay talks about they can't move the furs because the North Saskatchewan River had no water. Well, today there's a city of 1 million people on that river. Okay, I'm going to try to use this iconic image. North America, bathed in water, surrounding by ocean. 3/4 of the earth is ocean. The Pacific Ocean is 1/3 of the earth, and that's where we get our water. There are 3 storms, those swirly clouds, 3 storm systems forming over the Pacific Ocean and passing over Western Canada, bringing us water. The problem is, most of the Earth's global warming isn't land, it's water. The oceans are taking up most of the excess heat that we are producing by trapping energy next to the Earth. And so the oceans are heating up, they're producing more water vapor, and therefore when we get weather systems from the Pacific, they have a higher concentration of water vapor than they used to. And that's why one of the most reliable scientific predictions is that every time it rains or snows now, it's a little bit more intense than it used to be. The intensification of our weather systems. So if you think Saskatchewan's weather is variable now, just wait 30, 40, 50, 60 years in the future, because the weather's getting wetter and the dryer is getting drier. The weather's getting wetter because we're producing more water vapor, or the ocean is, and the warmer air holds more water vapor, and it's getting drier because if these weather systems don't come to Western Canada, if they go someplace else, and we have no precipitation, we have a lack of precipitation, but in a warmer climate. And so the droughts are also more severe when we don't get water. Now, I mentioned that our winters are getting warmer. We should all, at the end of my talk, take a break and do a bit of a dance and celebrate, because doesn't that sound good? I mean, there's big advantages. A study just came out yesterday from Agriculture Canada said we can expect crop production to increase quite a bit because of the longer, warmer growing season. And actually, Bill Heron, who's in the third row, and a colleague from PFRA did a study like that, 2001. One of the first studies that PARC sponsored with PFRA. So the forecasts are for increased crop productivity as a result of a warmer climate, if the producer can withstand too much water and too little water from year to year to year. Finally, if you really want to see the impacts of global warming, go to ecotones like this, where the vegetation grades from trees to grass, because the position of that ecotone is very sensitive to small changes in climate. This is from the Cypress Hills. I took this picture when the sun was rising in the fall. It was cold, my hands were cold, but not as cold as they used to be. And think about it, how different is the climate in those trees as opposed to the mixed grassland in the distance? We're talking about a distance of a few kilometers and that they're two distinct ecosystems. A very small difference in climate, in moisture and temperature over a short distance produces two different ecosystems. And therefore, as our climate changes, you would expect to see a response of the ecotone. And Mark van der Wal and his students work in the Cypress Hills and are doing that kind of research.
Hi, my name's Ingrid, and I have a degree in environmental sciences and ecology from Trent University, but a long time ago. But I follow things. One of the things I wondered about are tornadoes. It might increase in the prairie regions simply because you've got these huge differences in temperatures on, as you said, the oceans sort of provide a lot of difference on both sides of the continent. And I wonder too, there are so many deserts just below us who in the States that are producing a massive amount of heat, and then we get the cold air from the north. So, and I know when you have massive differences in temperature colliding and winds, you may get more but we haven't had that. That's just an idea I have. I have no proof. Ingrid, yeah.
Ingrid just gave a very good explanation of what causes tornadoes. And in theory, because tornadoes form where warm, moist air meets cold air, and because the air is getting warmer and moister from the Pacific, you would expect an increase in the intensity and possibly the frequency of tornadoes. In theory, but it's really difficult to confirm that because how many tornadoes do we get? We have a fairly small sample size of tornadoes in Saskatchewan. Like tornadoes occur, and it might be noted in a weekly rural newspaper, but the number of tornadoes that we actually observe is relatively small, which makes it difficult to determine if there is a trend in the size and number of tornadoes.
I heard you say our water comes from the glaciers and the Rocky Mountains, and it's pretty easy to see them receding. I can see that in my own experience. And yet we're developing mining systems where we require water to dissolve potash and bring it to the surface. And when it gets saline enough, we bury it, right, after it's done. So how long can we keep this up, that we're using a declining water source and basically burying the water we've used?
Mm-hmm. Did you hear that question about the use of water for solution potash mining? By far the largest consumer of water in Saskatchewan is the potash mines. And there's enough water to go around, especially recently because we've had some fairly wet years. And potash contributes a lot to our economy. At the same time, if I was a potash company, I'd be concerned about the possibility that we could have a drought a decade in length in the future. Because if there isn't enough water to go around, do you shut down the potash mine for 10 years and come back? I don't know. I think the large potash companies should be doing some strategic planning, some contingency planning, based on the potential for a severe drought in a warmer climate.
I'm just thinking about the event that you talked about. I assume it was Edmonton on the Saskatchewan River, and the fact that there was no flow. Now that doesn't sound like a drought, that sounds like somehow the glaciers are turned off.
Yeah, that's a really good point. He was asking the comment I made about the North Saskatchewan River. And just an anecdote, that information was collected by a student who was working for me, and I sent him to the Hudson Bay Archives in Winnipeg and said, see what you can find out about the 1790s. And he contacted me and said, check this out. At Fort Edmonton, they couldn't move the furs because there was no water in the river. That student was Jim Daschuk, who was a professor in kinesiology at the U of R and wrote a fabulous book, but that's beside the point. But anyway, yeah. And when I got that information, ironically, a short time afterwards, this was around 2009, I was scheduled to have a meeting with the board of directors of EPCOR, which is a large company, which manages the water supply of something like 85 cities, including Edmonton. Edmonton's our biggest client, and now Regina. And I said to the senior vice president, I said, did you know that the river outside your door, from the boardroom we could see the river dried up in 1794. EPCOR has been supporting our research ever since. We've had 10 years of generous funding from EPCOR. Because prior to that, they weren't even thinking about climate change. It wasn't even on their radar. And you're right. We don't know why the river fell that year because we don't have any hydrological data. We don't have any weather data for 1794. We only have this observation that the river was low, but also in our tree rings from Alberta, there's a narrow tree ring that year, so it was a dry year. So the trees agree with that observation from the Hudson Bay Company.
But it needs more than a dry year. It needs something to have happened to the glaciers simultaneously.
And it could have been a really cold year, so the glaciers didn't melt. That's entirely, because that was in the Little Ice Age. That was during the Little Ice Age. And so it's entirely possible that not only was it dry, and there's research to suggest that the droughts of the Little Ice Age were cold, dry years, where we think of drought as being a hot year. So there can be an absence of precipitation in a cold year, which could have been the case, at Edmonton.
So I was wondering, I think earlier on in the talk you used tree rings for to find like a heat trend, and then later on you used it to find a water trend. So can you find those both at the same time, or does it matter the type of tree? Or
it matters, the elevation matters. So at the highest elevations it's cold, and the trees record temperature. At the lowest elevations, where the trees give way to grasses, it's dry, and they record moisture. And they are different tree species because it's a different ecosystem. At the highest elevation, it's tamarack and subalpine fir and whitebark pine. At the lowest elevations, it's Douglas fir and lodgepole pine and limber pine and so on. Yeah. You bet.
So your graph showed a significant effect of trying to predict how much greenhouse gases we're going to produce. Do you have any thoughts about methods that are being proposed for mitigating or reducing greenhouse gases, and what's your projection in the future of where you think we'll go?
Yeah. Well, first of all, PARC doesn't do research on the mitigation of climate change, but I follow that literature, and I have lots of colleagues who do that kind of work and so on. And obviously technology is a large part of the solution, right? So I think it's pretty obvious we have to invest in green technologies, and we have to invest in technologies that capture carbon dioxide and store it in the ground. Those technologies are going to go a long ways towards reducing the concentration of greenhouse gases in the atmosphere. But what I've been told by experts in the field is it's probably not going to be enough. that ultimately there has to be a transformation of behavior. We have to change our lifestyles, right? And nobody wants to do that. And show me a politician, Ralph, who's going to run for office on a platform of rationing. Each of us only gets so much energy a year. Each of us only gets so much water a year. And that you can only have one car, not 3 cars like we do now. We go back to the future. Because there was a time when there was a family car. And there was a time when people showered once a week, like Saturday night for church the next day, right? And there was a time when a 1,200 square foot bungalow, like in Whitmore Park, was considered a luxurious home, right? So it wouldn't be a huge sacrifice to transition back to that lifestyle, but how? Good luck.
You mentioned our myopic thinking and our instinctual behavior to think about the present. I'm wondering if you know if the city of Regina is starting to strategically plan for droughts by, I don't know, storing water or methods just to prepare for 40 to 50 years from now when you have those huge fluctuations.
Well, at PARC, we've been working a lot with the city of Edmonton, city of Calgary, a bunch of smaller cities. Just about the only city we've never worked with is Regina. And when we ask, they say, well, we've got this great big reservoir to the west called Lake Diefenbaker. And it's big enough and deep enough that we're not going to have a problem with water. Now, if somebody can correct me, maybe there's been a change in attitude, but from the perspective of climate change policy, most cities in Canada are quite a ways ahead of Regina. Yeah. Just the way it is.
Yeah, my question is about line 3 coming from Hardisty, Alberta, going to Superior, Wisconsin. The tar sands. What would happen if there is a decade of drought? Would that affect the tar sands?
Yeah, good question. Yeah, in fact, we've done research for what's called the Canadian Oil Sands Innovation Alliance. COSIA is sort of an umbrella group for all the big players in the tar sands, you call them like. And it takes quite a bit of water to process the heavy oil. And they're supporting a lot of research to make the use of water more efficient, to recycle water, to come up with a process that requires less water. But they supported us to tell them how much water has been in the Athabasca River for the last 900 years and what the impact of climate change will be on the Athabasca River going forward. Now, the big advantage they enjoy is that there's hardly any other use of that river. About the only human use of the Athabasca River is processing of the tar sands. If there were any cities in northern Alberta, if there was farming in northern Alberta, I think that there would be a bigger issue in terms of whether there's enough water to go around.
What about non-human use?
Yeah, for sure. Environmental flows. Yeah. Yep. Yep. For sure. Lots of toxic. Yeah.
You've given many talks throughout the province, and I'm just curious to know if what you've learned from speaking to audiences in communities throughout Saskatchewan about literacy, about climate change, and about reactions to your research, the research that you present.
Reactions. Well, last week I spoke at the Western Canadian Crop Production Show in Saskatoon to an audience of several hundred farmers. And as soon as I finished, one of the farmers came up to the mic and just tore a strip off of me. And there was a young reporter there from, I think it's CKOM Radio, young reporter, and he wrote it up and put it in the online. And our former colleague, Dina McMartin, who's at the U of S, posted it to Facebook. And the reporter said, Professor Sauchyn remained remarkably calm. What else can you do? People screaming at you, and yeah, and I've been on open line talk shows on CKRM and so on, and callers phone in and call me a baby killer and I'm the devil and stuff. And okay, what can you do? You don't want to get in a debate with these people. And one of the more humorous reactions is I get people coming up to the mic and say, young man, which I like that part, you need to read the internet. I said, no, I don't. I don't get my science from the internet. I have lots of postdocs and grad students that I don't need to go to the internet. Calgary City Council. I was asked to explain climate change to Mayor Nenshi and his council last spring in the council chambers, and 2 of the council members are very much climate change deniers. And one of them said the same thing. This councillor said, you need to read the internet. And I responded the same way. I don't read the internet. Another council member who's quite a bit greener was on Twitter posting what I just said. Apparently, I'm not on Twitter. So, but it was in the Calgary Herald the next day. Saskatchewan scientist sparks debate at City Council because this council member wouldn't back down, and Mayor Nenshi got out his, it's called a gavel, or was pounding on his desk. Hey, order, order. Tried to toss this guy out of the council chambers, and I triggered the whole thing by just saying, I don't need to read the internet. Yeah, so. But you know, you have to empathize with these people. You can't condemn them, right? They have their view, and it's valid from their perspective, and so, yeah.
You talked about the global picture, and I know that Saskatchewan is one of the highest emitters per capita in Canada, and we are also higher, our climate is rising faster. I'm also aware that Canada produces about 1.6% of the global greenhouse gases. So are we basically at the mercy of other countries to save us, or is there some segmentation that we can, like, we can do something in Canada that impacts Canada?
Mm-hmm. That's a really good question. I'm not necessarily the best person to answer that question. You'd want to speak to a policy person, but I hear that argument quite often that Canada produces so few greenhouse gases that why do we bother with a carbon tax and other policies? But you could argue that Canada is showing some leadership, right? Somebody has to show some leadership and lead by example and influence other countries because we can. You know, we have the resources to do these kinds of things. And you're right, in terms of per capita emissions, nobody produces more greenhouse gas per person than Saskatchewan except Wyoming. But there's only 500,000 people in Wyoming. And they mine and burn coal. Yeah.
Dave, could I just, in your basic thesis, I take it, is that there will be, based on your scientific analysis, there will be more moisture and precipitation coming off the Pacific Ocean and across the mountains, and ultimately into Saskatchewan. But the challenge will be its total unpredictability, that it will come in deluges, and then we'll have these decade-long droughts. And that is one of the critical problems to manage. Overall, we may have more water, but it will not come in a steady, consistent, annual, predictable flow. It will come in these debilitating cycles of droughts and floods and droughts and floods. And our climate change challenge is managing that unpredictability and high variability and greater severity of both ends of the equation.
It's perfect. You just completely summarized my entire talk. We need somebody like you in Ottawa. Yeah, because, you know, we talk about on average, it's getting warmer, and on average, there's more precipitation. But what does average mean in Saskatchewan? You know, the average temperature of Regina is, I think, 2.7 degrees. Well, so what? It's the variability, the volatility, and I won't necessarily say unpredictable, but just dealing with that range of water level if you're a farmer or a municipality or any other kind of industry that requires a stable and reliable water supply.
I wanted to ask a question about that cognitive bias that you talked about. And again, assuming that you're correct in saying that we're just not dumber here in Saskatchewan and Alberta. So what's the primary driver of that cognitive bias? Is it that Saskatchewan and Alberta are more dependent upon fossil fuel as a driver for their economy? Or what is the primary cognitive bias? What's the driver for it?
Well, Sheena is doing master's thesis research, and she's going to have the answer in about 6 months. But of course, we have some hypotheses based on research in other parts of the world. One of the strongest biases, of course, is confirmation bias, where fairly early in life, we develop a mental map or a mental model of the world, and we spend the rest of our life filtering information to confirm that. So we all do this, you know. Supposedly as scientists, we're supposed to avoid this, but we're human, that when we read, we accept information that confirms what we already believe, and we reject contrary information. That's a strong one, confirmation bias. Another very strong bias is what's called the in-group bias. We tend to share the same opinion with the people in our community, right? That's why there's such an urban-rural split, because people in the rural areas think one way, people in the cities perhaps think a different way, and you don't want to think in opposition to the people that you live with and that you work with. You know, this was all brand new to me. About just after PARC was created, I started giving these talks, and people told me that I didn't know what I was talking about. And at first it kind of, whoa, you know, I spend all day, every day studying this stuff, and they say, you're wrong. And I sort of had a bit of a crisis where I said, why don't they believe what the scientists are saying? And some scientists think all you have to do is talk louder, right? You just have to be more affirmative, and you have to give them more facts. Well, that's like, you know, when you meet somebody who doesn't speak your language, you talk louder. We all do this, right? Somebody is Asian or African and doesn't know much English. You talk louder to them. That's ridiculous. But scientists do the same thing. If you don't believe me, I'll just talk louder or give you, it doesn't work. People don't respond to facts. And that's when I discovered social psychology. And for a couple of years, I stopped reading climate science and I just read social psychology and thought, why didn't I learn this in university? Well, it's because I took engineering. And back in the day, there were no electives. I never had a course in social science in my entire life, so, but better late than never. It's just, and that's why, you know, that's why you can't study climate change in a vacuum, because if you're a climate scientist and you stick to your lab and to your discipline and you discover people don't believe you, it's because there's a whole other realm or domain of climate science, which is how people respond.
As far as water security, I'm just wondering if in the future what that looks like for Saskatchewan, as if the climate changes and the glaciers melt and our consistent regular, our water supply that we rely on right now becomes less sure bet, if the climate science indicates that the new weather systems coming in and bringing us water will kind of mitigate any concerns that we should be having about water security coming like 2030, 2050.
Yeah, for sure. I mean, it's really fortunate we have Lake Diefenbaker. Somebody had a lot of foresight. I guess Diefenbaker had a lot of foresight in building that reservoir. So we do have storage. I don't know if you were here in 2001 or if you were here in 1988. Those were extremely dry years. But we forget. We just, I have students in university that haven't seen a drought because we've had some dry summers and dry springs, but we haven't had a 1 to 2 to 3 year drought since 2001, 2004, something like that. Yeah. And go back and read the newspaper from then. It was pretty bad. Yeah. Old Wives Lake, the largest natural lake in southern Saskatchewan, dried up in 1988. And the salt on the bed of the lake was blown into the fields, and cattle were getting sick from ingesting this salty air, and it was bad. And if that was to occur year after year after year for a number of years, then we have a pretty serious problem.
Hi, Dave. I just wanted to get if you have any comments on the, given the information you've given us today in our conversations here, what is your opinion in terms of the ability of the agricultural sector to adapt to any of these scenarios that we're looking at in the future?
So the question was the ability of the ag sector to adapt to the kind of climate changes that we forecast. That was from Bill Heron, former employee of PFRA, an amazing government agency. I don't know. Who knows about PFRA? Good. I saw Ralph's hand. We've had this conversation about what a tragedy it was that PFRA was eliminated. But one of the reasons given for putting PARC's mandate is the Prairie provinces, but it was put in Regina, possibly because the minister was here, but the reason given was PFRA was here, right? The national headquarters of PFRA were in downtown Regina, and PARC's mandate was climate science in support of adaptation planning. And PFRA is probably the best example ever anywhere in the world for a government agency that was created as a result of a weather disaster, right? PFRA was created as an adaptation to a weather disaster and did some amazing work. So, so Bill was asking, what is the capacity of the ag sector? And I think he knows the answer is that the ag sector in Canada is incredibly adaptable. And they wouldn't be here otherwise. You think about the farmers came from a humid climate. They came from Eastern Canada, they came from Europe, they came from the US Midwest, and they came to the Canadian prairies, and they created a commercial agricultural system in a hostile climate. And so they know all about adaptation. They had to adapt to a short growing season. So in the future, it'll be different types of adaptation to too much water or too little water. But and it's a science-based industry, right? Which is kind of ironic. I gave a talk to the board of directors of the Canadian Wheat Board or Grain Commission. They met in Ottawa a couple of years ago, and and I talked to the board of directors, the national board of directors, so these are pretty astute farmers, right? And one of them said, you know, the reason we don't believe in climate change is we don't believe in the solution that's being proposed by the government. He said, after all, we have a science-based industry and we use science all the time. So you're probably right about climate change, but we don't want to admit it. Right? Because if they admit that the climate is changing, then they have to endorse the kinds of solutions that are being implemented by various governments, including a carbon tax. They would rather see that farmers get paid to prevent climate change by storing carbon, by storing water. I mean, they do that anyway, but they don't get compensated for it. Right? The farmers do that on our behalf. It's a public good, but they don't necessarily, they bear most of the cost. And so because they don't like the types of policy solutions to climate change, they don't like to admit that they recognize the science. And this was a young, very successful farmer.
So congratulations, Dave, on 20 years of work with PARC. Appreciate it. Thank you much.
Thanks, Bill. Yeah. Thanks for all the support from PFRA. Well, you're no longer there, but. And Jill worked there, yeah.
I think my question, Dave, is on the pine beetle, the forestry, the spread of the pine beetle in relationship with the change in climate. Have you done any studies on that to see how it's spreading because of either the droughts that might be there, elevations of the pines, something like that?
Short answer is no. And there's a forest ecologist in the audience who would know quite a bit more about pine beetle than I would. All I know is it's held up as a good example of what's likely to happen as our winter warms. I mean, the pine beetle has always been in our forest, right? But yeah, I would refer you to a forest ecologist.
A question about the IPCC and the predictions that are very conservative. And there are scientists who are critical of that conservatism, and there's scientists who think that we've reached the point of no return because of the feedback systems and the amount of greenhouse gases that are in the atmosphere already, and even how if we pull out the aerosols and pollution is actually protecting us a little bit right now. I wonder if you could speak to that.
In terms of the opinion of these scientists, I think that we've reached a crisis situation.
Well, perhaps that, but also what do you think?
What do I think?
Are you able to say anything about that?
What I think really isn't based on science, okay? I mean, I'm certain that there's global warming. And I'm certain that it's caused by human activities and it's unprecedented, and that we have to do something about it, okay? But as to where I fall on the spectrum, right, is more a function of my personality than anything else. I'm convinced of that. Because I have colleagues doing the same kind of research that I do, and we don't agree on how severe and how immediate this crisis is. And I think it's just a function of, and you know, I read a fascinating piece of, I read a lot of psychology. It's really cool stuff. For pleasure, I read psychology. And there was a study of people that hold extreme views, and it said they lack the capacity of And whether it doesn't depend on which pole they occupy at any issue, right? There's too extreme on any issue. It doesn't matter. They have that similar type of personality, that they lack any kind of doubt, self-doubt. I have enough self-doubt that I have to admit I'm not sure how bad the situation is. I think it's such a hugely complex problem. I don't know how you can say that the world's going to end, like some people are suggesting. Okay, so I don't know. Some days I'm optimistic, and some days I think we're toast.